All right, and we're back. Gotcha. All right, so we're going to go through, I believe this is chapter 10, 11, and 12. All right, bring us right up to where we are today. First one, all right. Remember with these problems, you want to make a rectangle. Okay, hold on, something's not working. All right, so given circles O and P, all right, P has a radius of 9, O has a radius of 16, find the common external tangent AB. All right, we want to, remember with these, we want to make our rectangle. So I'm going to draw a line. God bless America. Draw a line from P straight over to O, like this, make my rectangle. All right, remember this has a radius of 9. So if that is 9, then this is 9 right here. These are right angles, okay, because they are tangent lines. If the radius of O is 16 and that is 9, then this has to be 7, right? Okay. If that is true, give me 1 second. Let's go purple. Then this has to be 7 or whatever. All right. So if I connect, remember you connect these two. Right here is 16. This part is 9. So the whole thing is 25. And this is a right angle. So if you were to take this triangle out of the picture, okay, here, here, and here, this would be 7, this would be 25, and this would be x. You'd have to do the Pythagorean theorem. Now, this is a triple, so if you do know your triples, you know that it's 7, 24, 25. Or you can do 7 squared plus x squared to get 7 squared plus x squared equals 25 squared. All right, if you have any questions on this, let me know, okay? Next, here we go. I'm just pulling these problems from old tests, so or old quizzes and reviews. So if you want to study and you're done with your review, then I go look through your old quizzes or old tests, and that's a great place to review. Okay, first of all, we want to find the measure of angle CEF. All right, we have to ask ourselves, this is from chapter 10, where is the vertex of this angle? The vertex of this angle looks to be floating inside of our circle. So when it's inside of your circle, you do x or a plus b over 2 equals x, right? Well, in this problem here, if you follow CEF, it's that arc. If you follow it out, you're looking at this arc and this arc here. So we're going to add 58 plus 30 over 2, okay? Which ends up being 44 degrees. All right, find the measure of arc. I'm going to erase this. Find the measure of arc AC. Okay, well, AC is right here. Okay, well, is right there. There you go. All right, AC is right there, and it's formed by these two tangents. Remember, we have a tangent AW and a tangent WC. All right, remember the ice cream cone trick, where if I have a tangent-tangent angle, this angle here and the closest arc that it creates are supplementary. So the measure of arc AC has to be 100 degrees. Okay, 100 degrees. All right, I'm going to change this one. I want to change it to ADB. Okay, angle ADB. The vertex is outside of the circle. Remember, when the vertex is outside of the circle, you do A minus B over 2. Okay, A minus B over 2. Or, wait, that just erased the wrong one. No, buckets. All right, we'll keep going with it. We'll go 58 minus 20 over 2. Okay, and you end up getting 19 degrees for ADB. I want to go back to FAW, so I really should have changed this one. This one should be FAW. All right, the vertex of angle FAW is here. A is on the circle, okay? A is on the circle. But this one's kind of tricky, okay, because the arc that it forms, if it's FAW, the arc that it forms is all of this. All right, the arc that intercepts is all of that. And we found in part in number 18 that this was 100 and this is 30. So when it's on the circle, when it's on it, you divide it by 2. So that's 130 over 2, right, to get 65 degrees for FAW. All right, 3, 2, 1. Here we go. All right, we got to solve for x and y, also chapter 10. Sorry, okay. First, let's solve for x. All right, solve for x is the power theorem. All right, if we're looking at the power theorem, this is a chord power theorem. So that tells us that to solve for x, we got to do 6 times 12 equals 16 times x. Okay, or 16x equals 72. So x equals 4.5 whole buckets. Bam. All right, now let's solve for y. Y is out here. All right, y is an outside part. It is a tangent segment. So I have a tangent secant. When I have a tangent secant, I do the outside part. So y squared equals the outer, which is 8, times the entire segment, times the entire secant, which is 26. Okay. So I get y squared, 8 times 26 is 208. So if I try to break down 208, I believe it's 36 and 13, so y equals 4. Wow, y equals 4 root 13. Bam. And if you have any questions, you let me know. Okay? 3, 2, 1. Oh boy. The apothem of a regular hexagon is, let's see if I can get one, is 3 root 3. These are everyone's favorite problems. This is from this is from chapter 11, okay? The apothem, and some of us forget what it looks like, is 3 root 3. So that tells us that this line here is 3 root 3. There's our 90 degrees. I remember if this is a hexagon, and this angle is 60, and this angle is 30. Okay, so if this is 60, this angle here is 60, then across from 60 in your general case is x root 3. So x is 3. All right. So what does that mean? That means that this right here, this segment right here is 3, and this is 3 here, so the entire side is 6. How do you find the area of a regular polygon? It's 1/2. Good question. Perimeter times the apothem. So the area equals 1/2. 6 times 6 is 36, times our apothem, which is 3 radical 3. Remember to multiply your numbers together. 1/2 of 36 times 3, all right, is 54 radical 3 units squared. If you are listening to this right now, all right, and not just doing with no volume, put a star on the front of your paper, right next on the very front portion of the packet. All right, right next to your name. Here we go. Next one. find the area of the shaded region if the circle has a radius of 12 inches. All right, the circle has a radius of 12 inches. Okay, so this is a shaded region, so you got to do the area of the outer shape, which is our circle, minus the area of our inner shape, which is a square. Okay, the circle has a radius of 12, so that makes this 12 here. All right, if I construct this right angle, if this is a square, then this is 45. Oh my gosh. Wow. Let's try that again. Using this little thingy here, this little stylus. It's terrible. Use my finger. There we go. Wow. Oh man. All right, whatever. So x root 2 is 12, right? So if I divide by radical 2, I get x equals 12 over root 2. And if you rationalize that correctly, you multiply the top and the bottom by the square root of 2. You should end up getting 6 radical 2. I think we're professionals at rationalizing by now. Or hopefully, if you need some help, come find me. Not mean. All right, so if that's 6 radical 2, then each of these pieces is 6 radical 2. Okay, so that makes this entire side of the circle 12 root 2. Or square, excuse me. So if I want to find the area of my circle, you ready? The area of the circle equals pi r squared, so pi times 12 squared, which is 144 pi. All right. Area of the square equals side squared or base times height. Well, our base and our height are 12, each 12 root 2. All right, so I do 12 root 2 times 12 root 2, or I'm going to write it as 12 radical 2 squared. Remember, that's 12 squared times radical 2 squared, which is 144 times 2, which is 288. All right, so the area of the shaded is the outer minus the inner, so 144 pi minus 288. And a lot of us make this mistake. All right, do not subtract 144 pi minus 288. That'd just be silly. So there's your answer. All right, again, if you have any questions, come find me. You could write this as a decimal, I suppose. Here we go. Find the area of the segment or shaded region here. If the radius of the circle is 3 and AC has a measure of 60 degrees, and this is our radius here, and so is this. Well, if AC is 60, and this angle here is at the center of the circle, and this angle is also 60, okay? Now, we know that these two are radii, so they're congruent segments. Remember from the first semester that if these two are congruent, then these two base angles here have to be congruent. All right, so these both end up being 60 as, these end up being 60 as well. Sixty. All right, so I have an equilateral triangle with all sides of 3. Okay, so remember, if you want to find the area of a segment, you have to do the area of the sector minus the area of the triangle. The area of our sector, I'm crunched on time here, is 60 over 360 times pi, and r is 3, so r squared is 9, right? Which is 1/6 over 1 or times 9 over 1, which is 3 over 2 pi. This is going to go fast. The area of the triangle equals side squared, which is 3 root 3 over 4. All right, so the area ends up being the circle minus 9 root 3 over 4. The last problem is from last chapter. All right, if you're having questions with that one or having any trouble with that one, look at my review guide on